and I'm also a pod leader of pod 17. And along with it, I also have a stats exam, subjective exam in my primary degree, which has a lot more deep theories and questions. So I'm well prepared for explaining you all. And I hope you all will enjoy. Just a little disclaimer, I speak a lot fast, so might be I will go in a 2x. So you can say me when I have to stop or when I have to slow down. Okay? Just give me a quick heads up so we can move forward.
Yeah, go ahead.
Yeah, sure. So starting from the very basic, so stats is more about the data. So data is classified in two categories. One is qualitative and second is quantitative. Okay. So qualitative are in two sides, numeric and non-numeric, and quantitative is numeric only. Okay. Then they are further divided into nominal, ordinal. Nominal and ordinal, both the numeric and non-numeric of the qualitative data, and the quantitative data is divided into interval and ratio. This is means like not so important. Moving forward, now what is nominal, ordinal, and what is interval and ratio? So nominal is the names or labels only. It's like color. If there's a red color, blue color, yellow color, or the state from which state the student is. So yeah, there is no order of the things, and there is a no relation, or you can't say which one is better than which another one. Okay, perfect. Guys, I just need a like thumbs up from you all so I can know that you are able to get it. Wonderful. Now ordinal. Ordinal is they are ordered. They are first, second, third, better, best, but we don't know that how much better is the first one is from the second one. Example, college immersion was better than Delhi meter. We know that. But how much better it is? We can't quantify it. So that is an ordinal data, right? Moving forward, internal. Internal is more like ordinal, but you can tell there's a gap. You can tell that how much better the one is from another. Like temperature, 17 degrees Celsius, 78 degrees Celsius. Another factor about interval is here the zero is not like nothing. Zero is holding some value. It's like when we say there's a 0 degree temperature in Delhi, it doesn't mean कि temperature ही नहीं है. There's a temperature, it means there's a cold temperature. Zero has some value. It doesn't mean nothing. But in the case of the ratio, it is also similar to interval, but zero means nothing. If there's a weight or height of a person, we say there's a zero weight, it means there's a no weight. If we say there's a zero height of something, it means no height of something. Are we clear?
Yes.
Perfect. Am I going very fast or do you want me to slow down?
No, it's good.
It's good? Okay. Yeah. The recording is not it's like someone has asked is getting recorded, so I don't think so it is getting recorded. Harshit, can you tell me about it?
Yes, I am trying to record.
Okay, great.
But the
Now the
quality,
second is measure of the central tendency.
guys, please
Sorry?
don't expect the quality and the voice so good.
Okay, thank you. Moving forward, there is a measures of central tendency. Also, one more thing: are you able to like get the handwriting of mine? Is it okay? You are able to understand it?
Yeah, we can understand it.
Yeah,
Okay.
we
Yes,
can.
it's understandable.
Okay. So, what is the central tendency? It helps us to find the center of the data. Okay, it means like we pick up a one number which represent the whole of the data. We all know this. The first one is average, mean. Has a simple formula that sum of all values upon number of values. Okay. Then second we have a median. It is a middle value. So in middle value, what we do? Firstly, we arrange numbers in order, either in ascending, either in descending order, and then we pick the middle one. Okay. Now one theory question that can come is like when there was a mean, why we need median or mode? Okay. That's a theory question. So why we need a median or mode? That's the problem is there कि अगर there are set of numbers where like 10, 20 and 30, it's okay. We can use the mean average and we can find out that the middle value is 20. Okay. Using the median also the middle value will be 20. But if the I add another number which is 400. Now in the average the data will get mismanaged. If we go according it, so we will get an amount like just a minute. The average will be 115. Okay, but 115 is not representing the whole set of the data. It is far more uh, greater than the first three data. But in median, if we arrange it, we will get 20 and 30 as a middle value, and we will get a sum of it, and we will divide it. So we will getting a 25. It represents the data more likely than compared to average. So that's a theory question that why we get a median or mode when we already have the mean. Perfect. Move forward. Can you move forward?
Yes, go ahead.
Okay. Then the third one is mode. Mode is like pick the most frequent one. If there's an example, there's a data which have 4, 4, 7, 5, 7, 7, 7, 8. Then here, what will be the mode? Mode will be the 8, the 7, sorry, the most frequent one. Great. This is all we have for the central tendency. Then there's the measures of dispersion. The measures of dispersion tell us how spread out the numbers are. It's like how much difference is between in the numbers. Okay. So firstly, we also have a three formulas, or we say three types, and how we find out the dispersion. First is range. It is maximum value minus minimum value. Suppose the maximum score get by the student is 90 and the minimum score is 75. Okay, so here the dispersion is around 15. Okay, so here range is this 15, which is represented the numbers is spread out in the 15 numeric. Okay, moving forward, we have a variance. So what variance is? There is a formula of variance, that is a summation of xi minus x bar ka square upon number of data we have, the number of random variables n. Okay, and then is a standard deviation. Standard deviation is just the square root of variance. Are we clear? Guys, are we clear?
Yes, yes.
Notes, and then we will be solving the question. We will doing the sample midterm exam. Okay. Okay. Now let's talk about the probability. The probability is what is the chances of happening of an event. If you see a happening of event, what are the chances of winning or failure or getting a specific outcome about it? For example, क्या chances है कि Iron Man is a variant of Doctor? We never know. So this just we predict the happening of an event. So there is a normal formula for the probability, which is favorable outcome upon total outcome. Got it? Then there are two properties of probability. First is addition rule and second is a multiplication rule. Okay, and there is a condition that if A and B are not happening together, it means that A and B are not dependent over each other, they are independent. Okay, so the first one is addition rule. Addition rule for OR. When we talk about the OR, there is an addition rule. Okay, so that is probability of A union B is equal to probability of A plus probability of B minus probability of A intersection B.
Hello.
Is anyone saying anything? Anyone have a doubt? Okay, give me a heads up if we can go forward.
Sure, go ahead.
So, okay. For example, what is the probability of Harry getting in Gryffindor is 40%. Okay, and the probability of him getting in Ravenclaw is 30%. Okay, now what is the probability? Either he goes in Gryffindor, either he goes in Ravenclaw. Okay, so then we will plus the probability of Gryffindor and the probability of Ravenclaw. That is 0.4 plus 0.3 is equal to 0.7. Means like there is a 70% chances that Harry will end up in either in Ravenclaw or either in Gryffindor. Clear?
Yes, go ahead.
Sure. Okay, moving forward, we have a multiplication. Multiplication rule is like talking about and. In a simple terms, if I say, are you comfortable if I speak in a Hindi a bit?
Yes. Yes, yes.
Okay. Sure. तो एडिशन रूल इज या तो ये कर लो या तो वो कर लो, या तो मुझे आइसक्रीम खानी है या तो मुझे शेक पीना है. ओके, दैट इज एन एडिशन रूल. एंड मल्टीप्लिकेशन रूल इज मुझे आइसक्रीम भी खानी है, मुझे शेक भी पीना है. ओके, तो दैट इज समेशन ऑफ बोथ. Okay, so when we are talking about a multiplication rule, there's a formula which is probability of A intersection B is equal to probability of A multiplied by probability of B. Okay, example, that the probability of Iron Man attacking Thanos is 0.8. Okay, the probability of Doctor Strange attacking Thanos is 0.6. तो ये probability क्या है कि both of them will be attacking Thanos at the same time. At this point, we will multiply the both of the probabilities. Then we will get an answer of 0.48. Means there are 48% chances that both of them will be attacking Thanos at the same time. Cool? Are we clear till now?
Yes, yes. Go ahead.
We will solving a question for it and we will getting it according to it. There's a formula that we are given with the probability of B happening of B when A has already happened. देखो प्रॉब्लम क्या होती है, वी आर नॉट एबल टू फाइंड आउट कि कहाँ पे लगनी है Peirce थ्योरम. व्हेन वी हैव टू यूज दिस थ्योरम. तो जब तुम्हें दिया हो कि ये काम हो चुका है, अब बताओ ये काम कब होगा, एंड उसके साथ तुम इसका उल्टा वाला डायरेक्शन भी दिया हो. फॉर एग्जाम्पल कि तुमने खाना खा लिया है अभी बताओ तुम पानी कब पियोगे, व्हाट इज द प्रोबेबिलिटी कि तुम पानी पियोगे, ठीक है। एंड इसका उल्टा ये हो जाएगा कि तुमने पानी पी लिया है और अब तुम खाना कब खाओगे। आई नो दैट इज अ वेरी लेम एग्जाम्पल, बट यू आर गेटिंग कि हमसे उल्टा पूछा हो और हमें उसका सीधे 0.7, ओके। सो हम इससे नॉर्मली फाइंड आउट कर सकते हैं। ओ ओके, so from it normally we can find out that the probability of Rahul not coming home is 0.3. Means like it's very easy. 1 minus 0.7, so we get it as 0.3 because sometimes we are not provided the data of an another probability. Okay, so we have to find it by out it by our own. Okay. Secondly, we are given the probability that mother waits. Means like Rahul comes and the mother is waiting. The happening of the Rahul coming at home has already happened and the mother was waiting. So that's the probability is 0.9. And secondly, Rahul doesn't come, but mother still waits. It is given by 0.3. Okay? Did we get it? What all the data are we given with?
0.3 कैसे आया एक बार बताओगे?
Sorry?
0.9 और 0.3 कैसे आया?
This is the data set which we are given with. This is the question.
Okay.
Okay? Yeah. And now we are asked to find out okay, what is the probability of Rahul coming home depending on the mother is already waiting for him. Sorry. Okay. So if we can see what I was talking about, we are giving the opposite data here and we are asked about it completely opposite. Okay. Firstly, Rahul was in a denominator, now it is in a numerator, and mother was in a numerator and now it is in a denominator. Can we see it?
Yes, yes.
Sure. Okay. So now the formula will be RC means Rahul comes home, MW is mother waits, and RDC is Rahul doesn't coming home, and MWC is mother is not waiting. Okay, I don't think so. We have that thing. We don't have that thing. Okay. So the formula will be probability of Rahul coming home, given that mother is already waiting for her or for him. Sorry. Okay. So this will be the formula. If you can see. Any doubt? Yeah, sure. If we go, like I am explained from the basic formula, which is we all will be getting the formula sheet. Okay. So we are asked what is the probability of happening A when the B has already happened. Okay. So we take out it by the probability of B when A has already happened multiplied by the initial probability of A divided by the whole probability of B. Okay.
Okay.
Yeah. Like there's a good example of it. I will share the YouTube video where you will get a practical example. I may not be able to explain it in a that way good manner that how this like formula is derivated, but I will share the link. It is just a 2 or 3 minute video. You can go it and you will understand practically that how is this possible and how we are multiplying it all. Cool.
Okay, thanks a lot.
Oh, welcome. Thank you. Okay, so moving forward, we get this formula. Okay, where's the probability of mother waiting given that Rahul is coming home multiplied by the initial probability of Rahul coming home, which is whole divided by the probability of mother waiting. Right? So when we see this, we find out that we are not provided with the probability of mother overall waiting for Rahul. Okay? And at this point of time, we will use both the formulas of multiplication and addition. This is a comprehensive question I have taken. Here we will talk about multiplication and addition also, and then we will solving the base theorem. Cool?
Yes.
Okay. So firstly we will finding out the probability of mother waiting. So finding out that we will be doing, so we are given with the conditional probability of mother waiting and Rahul coming home multiplied by the Rahul actually coming home. Okay, means like conditional probability multiplied by the initial probability, then we will get 0.9 multiplied by 0.7 is equal to 0.63. Perfect. And then we will be adding the probability of mother waiting and Rahul.
Is this the formula of total probability?
Sorry.
Is this the formula of total probability?
Yeah, it's the formula of total probability. Okay.
Yes.
Now we are putting that value over the first equation that we have gone through. Okay. This is by 0.7 divided by 0.72 is equal to 0.875. Means there's a 87.5% chance that Rahul is coming home regarding the fact that mother is waiting. It's like whenever the mother is waiting, there's a high chance that Rahul is coming home. Means woman instinct is something called. Okay. Are we clear till now?
Yeah.
Okay. Any doubt till now? Because this. Okay. Thank you. Good. I'm not too much, but yeah. The probability of Rahul not coming home.
Yes.
This is a formula for the total probability. Okay. So by putting all the values in the formula for the total probability, we get the probability of murder actually waiting.